Technology, industry, and the future. Technology and industry. While the words may conjure up different images in our minds, these two broad concepts are undeniably intertwined and totally codependent on each other. In another word, inseparable. After all, what kind of industry runs without some form of technology, and what technology could be produced without some form of industry? But how does one really define the roles of these two pillars of production? Well, according to the Merriam-Webster Dictionary, technology is a manner of accomplishing a task, especially using technical processes, methods, or knowledge. Industry, on the other hand, is defined as systematic labor, especially for some useful purpose or the creation of something of value. Quite simply, if technology is the brain, then industry is the brawn. Now, this doesn't mean that industry always follows technology's lead. Indeed, much of our technological advances have derived from industrial necessity. For example, when Henry and Seeley Fordrinier developed the first paper-making machine to make paper in a continuous roll, it wasn't because of a demand for longer sheets to write on. Paper and paper-making machines have been around for centuries. Instead, it was the industrial drive to produce paper faster and more cost-effectively. However, when we look at much of today's modern technology, we see the results of hard work by companies who strive to develop tomorrow's technology today. Case in point, Intel, the world leader in PC processors and microchip technology, has a gentleman working for them by the name of Brian David Johnson, who carries the prestigious and somewhat enigmatic title of futurist. His job is to try to look years into our future and foresee what technology will be demanded so they can start developing it right now. This process, called futurecasting, is all about developing a vision for the future by considering research, global trends, and what people expect to be able to do with technology 10 or 20 years down the road. So, what happens when a tech company fails to foresee future trends? Well, let's look at Smith Corona, a designer, manufacturer, and marketer of typewriters, word processors, electronic reference products, and accessories. They had managed to build quite a successful typewriter business, which began in the late 19th century. However, their business quickly declined in the late 1980s when personal computers, capable of performing more sophisticated word processing functions and so much more, began to replace the typewriter in both office and home. Smith Corona struggled, trying to expand into new markets with some computer products, but in 1995 they finally filed for bankruptcy. They are still around today, but have not managed to rebuild their once well-renowned corporate presence. Of course, that was a technology business. What about non-tech companies? What if a business deals in antiquities or topsoil? While companies like Intel, Apple, and GE work to advance society with new innovations, many businesses that aren't technology-based still need to work hard to stay on the cutting edge. Production methods, communication, and marketing methods are continuously evolving to make companies energy efficient, faster, and more in touch with their client base. Those companies that fail to update their technology run the risk of going the way of the dodo. Even Brotherhood Winery, a company that brags at being the oldest continuing winery in America, has a well-developed website with an online store, and they can be followed on Facebook. It is important to mention at this point that there are some issues with integrating new technology. The first issue to address is cost. Before any business considers purchasing the latest in technology, they must take a serious look at the projected return on investment, or ROI. For example, in 2009, a consortium of 5 major Hollywood studios implemented plans to invest over $1 billion to upgrade 20,000 theaters across North America to digital and digital 3D. They were able to justify this expense because of the reduced cost of prints and distribution that would more than cover the initial investment, while we, the moviegoers, were able to enjoy clearer pictures and jump out of the screen 3D movies along with our overpriced popcorn and sodas. It is also important to realize that costs may go well above and beyond equipment. Training, restructuring, and maintenance will also add to upgrade expenses. Another issue that crops up with technological advancement is unemployment. A common result of improved tech is labor efficiency, the general ability to accomplish more with less. While this is a wonderful thing for businesses to achieve, it's not so appealing to members of the labor force who may find they have to learn a new trade to stay relevant to the new modern-day labor demands. The last concern with technology advancement in an industry is the chance that a new technology will cause production and distribution industries to lose relevance altogether. When music formats moved from CDs to MP3s, the consumer gained the ability to manage his or her own music supply much more directly. CD producers and in-mall music stores are getting to be pretty much a thing of the past. It is this very issue that brings up my last point as we look to the future of technology and industry. Let's start with a quick glance at the past. In 1984, a gentleman by the name of Charles Hull invents a new process. This process, called stereolithography, is a very impressive word that basically means 3D printing. The first fully functional 3D printer was produced in 1992 by a new company which Charles co-founded called 3D Systems. In 1999, the first human organ that was lab-grown around a 3D scaffold was successfully implanted into a person. By using the patient's own cells, the risk of rejection was virtually eliminated. In 2012, using a mix of these two technologies, a fully functional kidney was printed directly from a 3D printer. In 2005, Dr. Adrian Bowyer from the University of Bath founded an open-source initiative called RepRap to build a 3D printer that was able to print most of its own components. In 2006, a new 3D printer called a selective laser sintering, or SLS machine, was developed. This new printer uses a laser to fuse different materials into 3D forms. In the same year, a company by the name of Objet produced a 3D printer capable of printing with multiple materials at the same time, allowing for composite prints with a variety of properties and densities. Now, in 2008, several things happened. The RepRap project successfully released plans for Darwin, the first self-replicating printer. A company called Shapeways starts a co-creation service allowing artists, architects, and designers to inexpensively create 3D objects. And for the first time, a person walked using a prosthetic leg that was produced with 3D printing technology. In 2009, the first human blood vessel was successfully printed. 2011 was filled with 3D firsts. A company called iMaterialize began to produce custom-printed gold and silver jewelry. Core Ecologic produced Irby, the first car with a completely printed body that got 100 to 200 miles to the gallon. And engineers at the University of Southampton designed and successfully flew an unmanned 3D printed aircraft. Finally, in 2012, doctors and engineers from the Netherlands created and implanted a 3D printed lower jaw into an 83-year-old woman suffering from a chronic bone infection. It is quite obvious that 3D printing technology, also called additive manufacturing, will move a lot of production into a different direction. But in what way? Some believe that this technology will reduce labor, outsourcing, material costs, and development costs for many of today's manufacturers. Others believe that many manufacturers will become irrelevant to our future society. Already, individuals are sharing electronic files for printing parts at home, from toys and knickknacks to parts for guns. Production at home is becoming a relatively inexpensive option. Imagine if you had company coming for supper and you realize you're shy one-place setting. Well, just load the right file, click on print, and voila, you're all ready for extra guests. Your wife doesn't have a necklace to go with the outfit she just brought home, so she finds a design she likes on Pinterest, picks a color scheme, and has a necklace with earrings to match in a few hours. Will this be the future of manufacturing? Will software and computer files replace our cheap made-in-Taiwan imports? Will organ donors be a thing of the past? Well, I can't really say for sure, but maybe our Intel futurist, Brian David Johnson, is the only one who knows for sure.